Okay, this looks like it's working. Okay, I think this works now. Maybe one of you can post a link to this on Piazza, so that all the other students have the correct link. I'm not sure if that's the same link or a different link. If you're on it, it means you have the right link, but I'm not sure everybody has that link. So maybe I can do that too, but maybe one of you can just post it on the same post that had the original link to this office hour. Okay, and sorry about the disruption. I just had to reboot my computer. The microphone didn't work, but once I rebooted it, and now it's working fine. Let's see, I can also try to put the link. Thank you. Okay, so now I'll go back to the web page. Now let me know if you have any questions. I'm don't think I have questions so far, so let me know if there are any questions in the chat window. How are things so far, by the way? Are you you think the first homework and the first module, maybe second module, are they okay? You think there's any big feedback you want to give me? Okay, so while you're thinking about that, let me start looking at the questions here. So the first question, can you talk about your work at Amazon? What tools were you using? Any highlights you can share? At Amazon, I worked on a number of projects. I was at the central machine learning team, and we worked on several different applications or products. One was recommendation systems for Amazon Video. So trying to predict which videos to show different users as they come to Amazon Prime Video website, and that's a very important problem for Amazon, since they spend a lot of money on content. They want to make sure that on licensing content, they want to make sure that the people that are interested in the content get to view that. So that was one of the big projects I worked on, and there were a few other projects. One was on customer reviews. So when you go look at an item you want to buy, you see different reviews by customers. So I was trying to, me and the team, we were trying to look at reviews. We sometimes had hundreds, thousands, sometimes tens of thousands of reviews for the popular items. The customers typically don't have time to go over thousands of reviews, so try to figure out how you can summarize some important information from that collection of hundreds or thousands of reviews and expose that to the user. Regarding tools or techniques, I'm not sure how much I can share. I'd rather not share details. I don't work there anymore, and Amazon is a place where the culture is probably to be careful with disclosure that are not done in an organized way. Okay, next question. When can we expect homework 3 to be assigned? So it will be sometime this week. And actually, I'm also working on the project. And I'm still debating whether to have homework 3 accompany module 3, or to just cancel homework 3 and instead of homework 3 give the first part of the project. And I'm leaning a little bit towards doing that. So you may not get homework 3 to accompany homework 3. Rather, you have project part 1, and that will roughly accompany module 3. And then we will have 3 more homeworks, and they will accompany modules 4, 5, and 6, but they will be a little bit later. So the way it looks now, I'm working on the project, and I'm trying to release the first part of the project this week, or at least by the end of the weekend. How does one know what bin size to use in a histogram? So there is a lot of theory in statistics that was developed on that. There's equations and asymptotics and all sorts of algorithms that you can prove different nice properties for automatically selecting the bin size. But I think that in reality, so these work well in it's one of these cases where theory works well in theory, but practice works well in practice. So based on what I've experienced and what I've seen in industry and in other places, when you try to analyze data, the question of bin width, people just typically they try different bin widths, and then they see what they look like, and they kind of take an aggregate of different bin widths and try to reason about a collection of histograms with different bin widths and draw conclusions from that. There is more importance to automatically determining the best kernel bandwidth when you do modeling, not when you do visualization, because visualization can be interactive. So it's not such a heavy tax or burden to try like 5 different bin widths. When you do kernel smoothing, you want to do smooth histogrammed or smoothed line, like that you saw in the second module. You can just plot it several times and look at all of them and reason about all of them. That's not so hard. But when it comes to modeling, and you want to have one model that you put in production somehow, and it needs to work pretty well, and you cannot have a human in the loop. The model needs to work day and night and be updated periodically, perhaps. Then you really need an automatic way of determining the bandwidth. And there are algorithms for doing that people actually use. But these algorithms are not so much based on the theoretical derived algorithms that I mentioned earlier, with all the nice properties and so on, and theorems and so on. Rather, they're usually based on cross-validation. So you keep some data set aside, you build a model with different bandwidth, and then you just see how it performs on a separate data set, and you pick the model whose bandwidth performed the best on the held out data set. Now, the reason I kind of talked about bandwidth, even though the question was about histograms, is that these two are related. So I kind of decided to take your question more broadly. Rather than just talk about bin width for histograms, talk also about kernel bandwidth for modeling in addition. Okay, second, I guess that's a comment. So I asked for some comments, so I guess comments are now starting to arrive. Learn a lot from the second homework, would enjoy some more open-ended questions. Bring our own data set, for example. So bring your own data set. I don't think that's going to work well in such a big class with 300 students because of the need for efficient grading and efficient grading on a consistent scale, grading one student in the same way that another student is graded. And I think I'm going to keep doing the open-ended questions. I like them. I think part of the questions, part of the answer should be to figure out exactly what the question is. I think that's reasonable to expect from graduate students. And that's how things work also in life. You don't get a question and there is one missing blank and you need to fill in the missing blank. Rather, you don't have rules that constrain you. You have to follow this or that. Rather, what you need to do in life is solve a problem, and if you can solve the problem from an unexpected direction, then that's fine. And so what this means for purposes of grading is if I ask something specific, I ask you to do what I ask you to do to answer the specific question. But if I leave a question open-ended, like try to predict X from Y, and I do it, if I say try to predict X from Y using linear regression, then I expect you to try using linear regression. And the purpose is to evaluate, do you understand and can you use linear regression? More open-ended, and I say try to predict X from Y or Y from X, and I leave it like that, open-ended even more, then you're free to approach it in different ways. And yeah, if you are innovative and you have a good suggestion, a good solution that shows understanding of the material, then you should get good points for that, good scores for that. First homework was easy enough, except that it took way too long to get too much data. Thank you for the comment. I did not intend for it to take a long time to get the data. I was hoping you could do that relatively quickly. Yeah, I intended it for it to be simple, because part of the beginning is to just get started in R and just get going. So I think it makes sense for the first homework to be simple. Okay, next comment or question. If we're able to do all the analysis and display appropriate visualizations in Python, can we use Python? Nothing against R. I just use Python pandas extensively for work. Yeah, that's a good question. I think if I could probably have taken the course in that direction as well, where I say you can use R or Panda, or R or Python. So pandas, for those of you who don't know, is a package in Python that provides the concept of a data frame similar to R. And a lot of what you can do with R, you can also do with Python. It's not exactly the same, but there's some similarities. So I am going to, however, ask you to keep R, again, for the simplicity of and consistency of grading. I think that's going to make things very hard, especially in a large course. And students can ask also, what about MATLAB? I want to use MATLAB. It's not clear if let's say I can ask the graders to ramp up on all 3 languages for them to grade in. They need to understand the languages. And then every language has its own difficulties, which will kind of create issues on Piazza, and can we do it this way? This doesn't work, and so on. So I'm afraid I'm going to disappoint you a little bit and still ask you to do it in R. I hope that will serve some purpose in you learning a new language. But I do understand your request, and I would probably request the same thing if I were in your shoes. So yeah, regrettably, I will still ask you though to work with R. Okay, next question. For homework 1, I attempted to use GridExtra for the tables, but abandoned due to the R Markdown generated PDF large margins around the table. I then use Cable. Is there a better alternative? I don't know Cable, and I don't know a lot about R Markdown. I've used something called KnitR, KNITR. I imagine that there are some preferences or settings that you can set to change the margins in R Markdown. I may be wrong, so I can't say that with certainty. I may be wrong, but I suggest looking at the detailed documentation about R Markdown and see if there is a setting that you can change there. If there is none, and you still want to use, you just need to make a decision. Do you want to use a Grid Extra, and you want to have an automatically generate document? I suggest using what I used for the book called KnitR, KNITR. It's very powerful. It's very heavily customized. There's settings for everything. You can find settings for everything, for the margins, for the table, for basically everything. So you can really customize the document to be exactly the way you want it to be. And you can compile KnitR into both PDF and I believe HTML also. Or the other alternative is to just create separately the table as a PDF and then import it. If you're using LaTeX, import it into LaTeX or into Word. If you're using Word or whatever, just kind of build the document, not with R Markdown. There may be other ways of doing that though. You may want to post a comment about that on Piazza in case other people have the same problems. Maybe you can have some back and forth exchanges on what's the best strategy of supporting that. Okay, another comment here. Homework 1, in attempting to chart helped me get my hands dirty with R and know my limitations. Next question, can we take a real life problem and solve it in our project? Yeah, so that is the plan. I plan to take a real life problem that if you can solve it, that would be a big accomplishment. If you can do a good job, maybe you can even try and turn it into a business, although maybe that's not going to work out. But you could think about it or try it, or at least have a feeling that you're working on something that matters, something that is taken from the real world and something that people care about. So yeah, that is the plan. Okay, question from module 2. What is ... density ... So this is a way to plot a histogram where the y-axis is normalized to be a probability rather than counts. So if you just plot a histogram, the y-axis will show counts, and the bin will just show, the height of the bin will show the count of within the range corresponding to the bin. If you use the ... density ... what you get is a similar graph, but the y-axis shows probability, so that the area under the histogram sums up to 1, and the area under a single bin corresponds to the probability of a new sample falling within that bin. And I think I mentioned that in the book. In some cases, the counts are more intuitive and interpretable because you can immediately tie it to examples. So if a height of a bin is 50, well, you know exactly 50 samples fell within that range. You know exactly what it means. In other cases, the ... density ... leads to a more interpretable histogram, because the count by itself if you gather more points or less points, the absolute number of counts carries less information than the relative. And what maybe you really care in many cases is the probability, the relative probability or the relative counts with respect to the total number of counts. And you can get that with the dot dot density dot dot, but it's harder to explain to someone that is not familiar with the concept of probability. So if you want to create a report and show it to an executive that maybe doesn't come from a quantitative background, then maybe the histogram with the counts on the y-axis make more sense than the density one. In other cases, maybe the density or probability scale on the y-axis makes more sense. So next question is, can you please describe the large picture of the homework 3 or project in your mind? So I think I mentioned earlier, I'm thinking of possibly, I haven't made a final decision, but possibly canceling homework 3 or canceling or postponing it to module 4, and instead just have the first part of the project. And I'm planning on having the first part of the project revolve around pre-processing data and preparing it for modeling and visualization. So that will mirror the module 3, because I do want you to practice the material in module 3. So you just do that in the context of a project rather than a homework. I don't want to give more details now because I expect to write it down and release it pretty soon. Like I said, hopefully this week, maybe by the weekend, and I may still change my mind or change it. So I'd rather not describe now something that is not final. Okay. Another question. Writing my homework in RMD is quite helpful. I think NeetR can be used with R Markdown, like the literate programming style with RMD and NeetR. I agree. I think it's very helpful and it looks very nice. I really like that, and it's easy to generate. I think R Markdown is even easier, but Neat is also easy. It's much more powerful. NeetR is much more powerful. You can have much more control. In fact, if you take a look at the ggplot book in the resources section, so not my chapter, but rather the ggplot book written by Hadley Wickham. This is a book written entirely with NeetR, same as my book. But my book, I only give you 3 chapters. But ggplot book is an entire book written in R, and you can actually download it from GitHub and store it locally, and then compile it locally with NeetR, and you get the PDF. And then that's what I put on the resources. That's what I did. I cloned the GitHub repository and made sure I could build it properly on my machine. And after I built it, I got a PDF and I released the PDF. And you can see that the book, it looks very professional. So, and you can change the style. You can make it HTML. You can turn it PDF. You can make, different styles of fonts, sizes, all sorts of customization. And R Markdown is much faster. You don't get as much control, but it's much faster, and it's quite pretty, I think, pretty and neat. Okay, next one. My question on dot density was really an R language question. What kind of object is it in R? How does it come into scope? Ah, I see. Let's see, you put here scrolling up to see the original question. So to be honest, I'm not sure how to answer that question. I don't know. This is not sure what type of object it is. It could be a formula. R has an object type that's called a formula. So that could be it, and we'll see more formulas, more formula objects later on when we do regression. But I didn't look at it in depth and look at the code of the function to see what kind of object it is. I just used it as a user rather than try to figure out how the implementer of ggplot or qplot made it work. Okay, next question. Okay, in the interview videos, most of them say they use R only in prototyping, but for production they go with Java / Scala, etc. How hard is it to translate R coding to other languages? So I think that's a fair comment. Let me expand on it a little bit. So in many cases, most of the effort in data science and modeling is done offline, and then a model can be trained and stored offline, and then that model gets served to customers. And the task of building the model is more the task of the data scientist or the machine learning engineer, whereas the task to make sure that the model performs well in production is more task of the infrastructure engineers, the online infrastructure engineers. So for the online part, it's never R, and I think in rare cases it's Python. There are some cases where the entire stack is built in Python, but I think that's pretty rare. It's usually Java, Scala, or C++. For the offline part, so with the part where you analyze the data and you train a model, and you, even up to the point where you put it in production, you move it over to production, that part sometimes is done with R, sometimes with Python, and sometimes with the same production language that manages the online system. So there is an advantage to doing that in Java or Scala, that part, because then you have the same language to take care of the offline part and the online part. And at Netflix, this is often what is done. So the offline part, the training of the model and so on, that is in many cases done with Java and Scala. But before we get there, we need to do research and try different things and experiment and try different variations and different loss functions, different regularization schemes, how to interpret the signal into positive and negative and so on, the signal that we get from users. And that part is more difficult. It doesn't make as much sense to do in Java or Scala. Sometimes it is done that, but it makes the whole process much more heavy and difficult and slow. If you do that part in R or Python, it's much faster. And in some cases, also the offline training is done in R or Python. So I would say the online serving infrastructure is usually C++, Java, or Scala. The offline part that builds the model that is going into production and prepares everything for the online systems. In some cases, this uses the same production language as the online system, like Java or Scala or C++. So in Netflix and in LinkedIn, it was Java or Scala, and I know in Google and Facebook, they use C++. In some cases, that's the same language, and then the prototyping, the process of the iterative process of R&D, where you start with a concept and you try to improve, build a model, and then improve on that model, get it to perform better. That part is done in a language like Python or R sometimes. And then in other cases, the offline part is done completely in Python and R, although probably in large companies, because they have large code base, like Netflix, there's a fairly large code base. It's more maintainable. It's easy to work with if it's Java or Scala, and that's why R or Python is used for the prototyping stage. So that is the background. Now, specifically to answer your questions, how hard is it to translate R coding to other languages? I think it's not always easy. It's a challenge. So in some cases, what you do is you train a model in R, and what R gives you, let's say if you build a logistic regression or linear regression, R gives you a set of linear coefficients that describe the model. And then you take that vector or list of numbers and you re-implement inner product in Java, which is very simple. So in that case, and then you use that for scoring offline or online or both. And so in that case, it's very easy, but you don't recreate the entire code base in R, in Java or Scala or C++. That would be pretty hard. You just recreate the scoring function, which is the linear form, a linear combination of feature vectors. And that part is not necessarily as hard, because you just multiply each feature by weight and you sum it up. So that part is very easy to recreate in a production language. Okay, next question. Do you find that linear logistic regression are good / sufficient models for most of your professional work? That seemed to be the focus of the course based on the syllabus. I would say, I think if I had to pick two methods that are the most frequently used, they would be exactly these two, logistic regression and linear regression, and that is aggregating what I know about places like Google, Amazon, LinkedIn, and Netflix. But that's not everything. There are other methods that are important as well. Maybe number three, the third place I would put trees. So that is an important category. And another important category is clustering, or embedding in latent space, like matrix factorization. That's also important, and that happens also frequently, especially in recommendation systems, but also in other cases. And also, you see more and more deep learning coming up, especially when it's in the context of speech or vision or machine translation. I think virtually all the state-of-the-art methods use deep learning in these cases, and you would be probably not terribly smart, or if it's not an effective method to try to solve problems in vision, speech, or machine translation using non-deep learning techniques right now, given our current state of knowledge and what we know. So I mean, basically all, like I can maybe say like a short story about that. When I was a PhD student between 2000 and 2005, I was considering doing some research in speech recognition, and a few people working in that area told me, don't bother working in speech recognition. That was somewhere around 2000. Speech is fairly finished as a field. We got as good as we can. We cannot get any better. All the research that's done now, that's what they said back then, is incremental. You get it a tiny little bit better. You can get it better in one very narrow context. It's not a very productive area to work in. All the improvements are very small, and go pick something else. And I picked something else. And indeed, all the progress that was done back then was small and incremental. And then recently there was huge improvements in speech, and that was primarily due to deep learning. So you see, speech recognition of Google is actually quite usable. It didn't used to be like that. The same thing with Alexa and Siri. So that is a huge step function or huge jump in quality due to deep learning. And something similar happened in vision and Maybe not quite as dramatic, but similar improvement. And also, I think there was an improvement in machine translation. So now Google, Facebook, Amazon, Apple, when they do this kind of machine learning, they use deep learning. But I haven't seen deep learning getting in industry into other areas. So you see a lot of academic papers, deep learning recommendation systems, or deep learning whatever. I haven't seen that happening in industry. This is more papers, and papers have a tendency of not being representative of what is really happening. I think we're almost out of time. Thank you for listening, and I will say bye-bye because I'm being kicked out of my room.